Okay, in this video we're doing Calc AB Problem Set 117. The problems and a playlist are in the description below. Let's check out the problems. Number 1, we want to evaluate the derivative ddx of 8 to the 3x squared minus 5. So this is the derivative of an exponential function. So that's going to be the derivative of a to the u is a to the u natural log of a times the derivative of u. So we're going to start off with a to the u, which is 8 3x squared minus 5, times the natural log of a, so the natural log of 8, times the derivative of u, so the derivative of 3x squared minus 5 is 6x. And basically that's our answer. We can rewrite it because I think it probably would be rewritten, but we were done at that point. Good first question. Let's take a look at the next one. Find the area of the region in the first quadrant bounded by the curves y equals x cubed plus 6 and y equals x plus 6. All right, so I'm going to start off with a graph because I'm not really sure. So it's just x cubed but moved up 6, so it looks kind of like this. And then x plus 6 is just y equals x but moved up by 6. Really, this problem could have just been x cubed and x, and you would get the same result, just shift the entire region down by 6 units, but that's okay. We need to find the intersection points, so we'll set these functions equal. You don't need to watch that. I'm going to move everything to one side, or actually subtract off the 6's finally, and then move everything to one side, factor out an x, factor x squared minus 1 into x plus 1x minus 1, set it equal to 0, we get x is 0, x is negative 1, or x is 1. We only want the first quadrant region though, so we're interested in this point, which is 0, 6, and then if you plug 1 into either function, you get 1, 7. So that's the region that we're interested in. All right, so area of a region is the integral from left to right of top take away bottom. So our left bound is 0, our right is 1, and then the top curve is the linear function, so x plus 6, minus, put this in parentheses, the bottom function, x cubed plus 6. If you use parentheses there, you will make far fewer mistakes long term. So this gives us the integral from 0 to 1 of x minus x cubed. We're reversing the power rule here, so it's 1/2 x squared minus 1/4 x to the 4th from 0 to 1. So when we plug in 1, we end up with 1/2 minus 1/4. When we plug in 0, everything zeroes out. So we just get 2/4 minus 1/4 is 1/4 for our area. Pretty good, straightforward area problem. Let's take a look at the next problem. Let R be the region enclosed by y equals 8x squared, x equals 1/4, and the x-axis. We want to find the volume of the solid form when the region is revolved around the y-axis. Okay, so let's start with a picture. So that's basically 8x squared. I'm going to say that that is 1/4. I do need to know what happens when x is 1/4, what is y equal to, right? So y is going to be 8 times 1/4 squared, or 8 over 16, which is 1/2. So this point where they intersect is at 1/4, 1/2. That's important because we're going around the y-axis, so I'm going to need y bounds. So we are rotating around the y-axis. To do that, everything needs to be in terms of y, right? So the way that I always remember this is really, I think, when I'm going around the x-axis, that's like quote-unquote normal, and you go from x equals a to x equals b, and then your function is top is in terms of x, bottom is in terms of x. When you're going around the y-axis, you need your y bounds, so you need to go from y equals a to y equals b, and then your rightmost curve and your leftmost curve. So it changes your perspective. So I need to solve this for x so that I have my function in terms of y. So divide by 8, take the square root, you get x is the square root of y over 8. And you know that x needs to be able to be positive, so that's how you know that you're taking the positive square root in that case. Sometimes people get a little confused about that. All right, so we're going to have pi because we are rotating, and we're going to have these two radii, right? So your bigger radius goes from the axis all the way out to the edge of the region. That's just 1/4. So we'll have pi. We are going from y equals 0, right? So you're going from bottom to top. Y equals 0 to y equals 1/2. Those are y values. And then our bigger radius is 1/4 minus 0, so just 1/4 squared, minus our smaller radius is that function. It's the square root of y minus 8, y over 8, and then minus 0. So square root of y over 8 squared dy. Now this is just a normal integral, and you don't really think about it, you just kind of get going. So this will be 1/16, and then minus y over 8. Reverse power rule, so we get pi, the quantity, 1/16 y minus y squared over 16, and we're going from 0 to 1/2. When you plug in 1/2, you get 1/16 times 1/2 is 1/32. 1/16 times 1/4 is 1/64. When you plug in 0, it zeroes everything out. 2 over 64 minus 1 over 64 is 1 over 64 times pi, so pi over 64. Volume problems are pretty interesting. They're very common, especially free response. You'll almost certainly have to like set up one and do it on the AP exam. I have a lot of videos of finding volumes. Definitely recommend you check those out if you're kind of like shaky on this topic, because it's not a topic you need to be shaky on. This is one that you can definitely master with a little bit of practice. All right, next. Evaluate the derivative of natural log of x over x squared. So this is just a quotient rule problem. So the derivative of, all right, let's do it. Bottom, derivative of the top is 1 over x minus top, which is natural log of x. Derivative of the bottom is 2x, so 2x natural log of x. All over the bottom squared, which will be x to the 4th. We can clean up like kind of a little bit. We'll get x minus 2x natural log of x. You can take an x out of everything and cancel one x, so we will get 1 minus 2 natural log of x all over x cubed. I don't know, it's pretty straightforward, but there's nothing wrong with that. That's the entire problem set. I hope this was helpful, and good luck.